We'll start with the first topic in data structures called as sparse matrix. Before that, we will just revise the concept of a matrix. Matrix is nothing but two-dimensional array It is two-dimensional array of elements. Position is specified by row number and column number. Position of each element will be specified by the row number and column number. In memory, it occupies consecutive locations that is internally one-dimensional. Stored row by row, stored row after row. For example, if it is array A declared of 20 rows and 6 columns, then total memory allocated will be 20 into 6 into 2 bytes. So in all, 240 bytes of memory will be allocated for this array. It is stored row by row. So here you will have row 0 elements, then row 1 elements, then row 2 elements. Like that, this is going to be the elements of row number 19. And in each row, you will have column 0, column 1, up to column number 5. Again, column 0, column 1, up to column number 5. Like that, this is the last one. The start address of the allocated memory will be stored in array name. Got it? Make a note. for any element Aij, that is row number I, column number j element, address calculation you will have to calculate the offset. It will be always treated as base address, that is the start address, plus offset. Whenever we want to find the position of row number I, column number j element, then its position relative to the start address, which is also called as base address, is to be calculated. So from here at what distance? That is the offset. So that offset will be calculated as base address is of course array name. When we want to say offset from here the position, it will be I rows are complete into number of columns. I am writing it in capitals. In this case, I will treat this as row by column. So this is what I mean by COL, not the column number. J nahi hai wo, number of columns. So it will be I into number of columns, because I rows are complete. Whenever we are talking about some element like A42, then row number 0, 1, 2 and 3, 4 rows are complete. And then in the next row you will have to skip 2 elements, you will be at the exact position. So you will have to skip I rows, each row having column number of elements, plus j. This is how that offset will be. This is how that offset from the base address can be calculated. And if we want to be more accurate than this, then of course you will have to multiply by the size. Means in case of integer you will have to multiply by 2. In case of float it will be 4, because then each position will consume those many bytes. This is actually total memory is row into column into size of each element. This is what we could say, that to calculate the position of ith row, jth column element. A simple calculation. And this is one reason, as this calculation contains the number of columns, whenever you write some function, say read mat, to which you are required to pass the matrix, the first position is empty, but the second one should be specified correctly, because this will come into picture in the calculation. If you don't specify that, then there will be trouble, there will be error. If you make a mistake in passing that, in writing that particular value, here I am declaring it as 20 rows 6 columns, and by chance if you have written the function as read mat having the parameter p and 5 columns, then outside it will be this picture, but inside here row number 1 will end, because it is supposed to contain only 5 columns. Then in this case, just before this fourth element, the next row will end, and ultimately the element which you are referring to as 0, 5 in main will be treated as 1, 0 inside the function. Got it? And that's why what you will read inside this particular function and what you will get outside will be something totally different. So one has to keep in mind that this value should match with this. Any mistake on the lower side or higher side will change the entire location, because the address calculation takes into account the number of columns in the declaration. Okay. Now coming back to the topic under consideration. This was just the revision. This is what we should have studied in the first semester. Now, in the first semester in numerical methods, when we tried to solve the simultaneous equations, actually in most of the applications, the engineering application might result in the set of simultaneous equations in which not all variables will be necessarily present. Like there could be 10 equations in 10 unknowns, but the equations may look like 3x0 minus 4x1 plus 7x2 equal to 13. Then the next equation could be 2x1 minus 4x2 equal to 10. Next equation plus say 2x3 equal to 10. Next equation could be minus x2 plus x3 plus x4 equal to minus 11, and like that. Of course, there will be n unknowns, n equations. Like in this case, I am giving only 3 equations, but there are 5 unknowns. So I will have to give 2 more equations. But then you will find that every equation is not containing all the variables, all the unknowns. In that case, those will be treated as 0x3 plus 0x4. Here it will be 0x0 plus 0x4. Here it could be 0x0 plus 0x1 and the remaining. In that case, the matrix that you are going to form might have several zeros in each row or in each column. Considering the case when I have got so many elements as 0, I will have to think about the total memory which is to be allocated. Consider a case of some 100 equations in 100 unknowns. What will be the size of the memory that will be required? Of course, these need not be always integers. Normally in the application area you will find that coefficients are float, and if you demand for accuracy, those will be double also. So if it is 100 into 100 into 4, that requires 40 kilobytes of memory. 40 kilobytes of consecutive memory locations. Got it? And to allocate the memory which is as big as 40 kilobytes could be a difficult task. But in scientific and engineering applications, this may even go ahead in 1000 equations, 1000 unknowns and something like that. Afterwards, in the next year, when you learn graphics, where we are required to actually consider the 3D surfaces, then each point has to be considered on that particular surface, and dependent on the resolution that we are considering, or the accuracy that we require, or the smoothness that we will require for the surface, then the equations could be even beyond this. And then you are required to store all those coefficients and then process them and fit the curve through them and whatnot. In that case, it will be very bulky. But then the set of equations will be always like any surface which might be having thousands of points, but still only these 4 points which are forming a small rectangle on it, they bear some equation among them. Means you will have some 100 equations, but each equation at a time will consider only 4 variables. Each equation at a time will consider only 4 unknowns. Then how much of the memory will be actually required? Because there will be only 4 values, 100 equations into 4, and this is pretty less. It is only 1.6 kilobytes. And you can just compare. there will be a lot of reduction in the memory requirement. See, whenever we talk about the efficiency of the program or the effective programming techniques, and when we try to evaluate the program that you are writing, then we will be obviously thinking on two lines. One is the memory required, and the second is speed. We are talking about efficiency. Accuracy has to be there. It's not that your program is giving you somewhat nearly the correct answer. ऐसा नहीं होता. It has to be accurate. Whether you write 2 lines for it or whether you write 100 lines, that is apart. Answer has to be accurate. That is the first parameter. But once two programs, they are giving the same answer for the given problem, then their evaluation will be done on two criteria. One is the memory, then the speed. This memory will take into account two parts, for data storage and the code size. That is the number of lines that you are writing. And also the data that you are storing is consuming how many bytes. Whereas speed will be how fast your program is giving the answer. Whenever we talk about efficiency, it is a golden mean of these two is to be achieved. Whenever we try to reduce the memory requirement, in that case the speed is likely to drop. You can use the bulky memory, but the speed will be very high. Because you will find that in this type of case, whenever I am solving these simultaneous equations, I will have to subtract each row not from other 99 rows, if you remember the Gauss elimination method, when I want to make the lower triangle 0, but each row is to be subtracted from other 3 rows only. And this is possible because I am consuming 40 kilobytes of memory. Then in that case obviously the speed will be very high, but at the cost of memory. When I try to reduce this memory to only 1.6 kilobytes, then I am required to keep the track as what is the position, because otherwise you are not keeping the track of the position. We are coming towards that sparse concept as such. Whenever you are storing the value, you are not bothered about the position because you are storing it in row number I, column number j position. When I try to minimize that memory, it will be mandatory that I will have to preserve the positional relation among these elements, and if the positional relation is to be preserved, in that case I am forced to store the row number and column number. Otherwise how will you store it? आपको पता कैसे चलेगा कि what is the positional relation among these elements? Right now they are placed at the appropriate position, so the relation exists. You must have heard the word relation also. Have you? So in sparse concept, we are trying to achieve this, reduce the memory. That means we are looking for storing only non-zero elements. And if we are looking for storing only the non-zero elements, then we must preserve positional relation. That leads to each element being represented as row number, column number and value. Whereas in the previous case, it was only the value. But when I store only the value, I will consume as much as 40 kilobytes of memory. When I go for storing for each element, it's row number, column number, and I will use one-dimensional array. Now in this case, this much memory is required only for storing the value. Additionally, row number and column number are also to be stored, but they are going to be integer values. If it is only 100 by 100, then it can be short int also, because short int is capable of going up to value 256. Integer is up to 32,000. So we don't have row number and column number of that value. So 2 more bytes will be required, 1 byte for row number, 1 byte for column number. So additional 2 bytes. So this was 4 bytes of float. So 4 plus 2 might lead to, instead of 1.6 it will be 2.4 KB, but still it is sufficiently low. And so we will tick mark this, saying that this is the representation I will use, because it is quite a great reduction in the memory. And if you are going to store each value in this manner, this is called as the sparse notation. So you will pick up only non-zero values and you will store their row number, column number and value. Suppose this particular, so all the values will be stored one after the other. It's a one-dimensional array, though it appears as two-dimensional. Suppose I don't have some position like 2, 5 in this. It ultimately means that 2, 5 element is 0. Got it? This is the need. Why do we require sparse? So our first job is to declare a structure for the sparse matrix. Of course, it is struct sparse I can say shortened row comma column float val. What is the structure or a record? It is going to be a collection of different data types, the objects of different data types. Purpose: they should occupy consecutive memory locations. It's a group where after storing the row number there will be column number in the memory and then the value. Okay. Otherwise you will have to use 3 different arrays, one for row number, one for column number and one for the value, because their types are different. And if you have seen the address calculation, it is always base address plus offset. That means to reach any element you will have to first go in that array of row and fetch the row number, that is one calculation, go in the array of column and again fetch the column number, one more calculation, and then go into the array of value. So 3 calculations will actually take you to the actual value, accepting the entire data. Whereas here the calculation will be done only once. From base address, this entire size will be taken, and so you can go to that position and then you will read the 3 values consecutively. So structure's main purpose is to have the objects of different data types to be stored consecutively in the memory. There is one more keyword, typedef, which will allow us to declare a new type name, which I am going to declare it as capital SPR. So here SPR is not a variable. If this word is missed, then SPR will be an identifier of struct sparse type. Whereas if you use typedef, it becomes a new type, and this type can be freely used as we use the other data types like int, float, char, etc. So now in my main, I can declare SPR types, say SP1 square bracket some size. Of course, I will be using something in capitals that has to be hash defined. So this size you can write anything, and some other declarations. But this is a type. Identifier, it is array name is SP1. And how will you access the elements? It will be SP1 square bracket I dot row. That means access the element at position I, and out of that, because in that element you have 3 parts, row, column and value. Out of that row, dot row. Dot can be considered as apostrophe s. So ith element's row number, ith element's column number, ith element's value. Any doubt? Second job is to convert a given matrix to sparse form. What is given to us? Float array A having m rows, n columns. This should be converted to sparse form. I have some matrix over here. In the sparse notation form, it will be represented as 0, 0, 4. Row number 0, column number 0, value is 4. Row 0, column 2, value is 2. Row 1, column 0, value is 1. 1, 1, 1. Then 1, 5, 7. Then 2, 3, minus 3, and then 3, 4, 16. This will be the sparse representation of it. But the sparse will lose the information that the original matrix was having m rows and n columns. because it is quite likely that I might have one full row of zeros. It's not that the case that I can find out maximum row number and maximum column number and I will come to know the size. The actual size could be a different one. I can have one complete row or more rows as zeros, or there could be some extra column which is a zero column. In that case the size cannot be indicated over here. So we explicitly use the first position, that is position 0, for storing the row number, that is number of rows, in this case 4, number of columns as 6, and how many values, non-zero values are there? 1, 2, 3, 4, 5, 6, 7. 7. So this first position 0 is exclusively used for storing the number of rows of the given matrix, number of columns of the given matrix, and the number of non-zero values. This is what I want to do from A to SP1 is the job. I have given the example purposely because I want you to observe that these values, as I am going to scan it row by row, they will be automatically arranged in the ascending row numbers, and when row number is same, it will be ascending on the column numbers. It will be always the case. That is the standard that we will have to follow. Always. Every sparse notation will result in the sorted form only. So to do this job, I am given this. So array A I have m rows are there, n columns are there, and somebody has already read the matrix. You can always read this matrix. That's no hassle. Job is to convert it to sparse. So see how I proceed. I will have to reach each position in this array A. That too moving row by row. That is for constant row number, all columns. And then if A of I is A, what should I write? Y greater than 0? Why not equal to 0? Y equal to 0? Forgetting the things. Where will the first non-zero value go? To position 1, not position 0. That means I will require some position for that SP, which will start from K. And then you will say SP1 of K dot row will be the row number of that non-zero element I. SP1 of K dot column is Z. SP1 of K dot val is equal to A of I Z. And I have consumed one position, K plus plus. Okay, and then after completing all this, what will be the last value of K? I have just filled the position number 7, and K will be at 8th position, because whenever I write certain, see there were 7 non-zero values. So this is the position 0, 1, 2, 3, 4, 5, 6, 7. Once I write the 7th value, then K will become 8. So when I complete this loop, K will be at 8, but how many non-zero values are there? 7. So minus 1. Now I will be filling up that 0th one. I will say SP1 square bracket 0 dot row is equal to m, because there are m rows. SP1 square bracket 0 dot column is equal to n, and SP1 square bracket 0 dot val will be K minus 1. And if you have understood this, then the job is pretty simple to convert it to a function form, because now I will have to declare only int I, j, k. Name of the function will be convert to sparse, to which I will be passing the sparse matrix where the result should go. It is always policy from right to left, right? So in SP1 the result should go of what? Of float A having some size, number of columns should be passed, and don't forget that I will have to exclusively pass int m, int n, because otherwise how will I come to know how many rows and columns are there? So you will have to pass size also, and then it will not return anything. This is in to out approach. I have first developed the logic and then I have converted it to the function form. So if by chance you are afraid of writing the functions, it's not a tough task, because till I write the function everybody was quite comfortable with this part. बाकी कुछ नहीं किया मैंने इसमें. Whatever is given to me and whatever is the answer generally we return if it is a single value. If it is array in which the changes are to be made, that should be passed. Okay, make a note and just think about, that is going to be my job 3, where for user he is inputting, just listen to it, they can take it down later. For user he will be inputting the matrix, like I will be inputting this matrix as 4 space 0 space 2 etc. when I had inputted it. Now my job was to, given the matrix, convert it. लेकिन कभी तो read किया होगा पहले. At that time I was inputting it like this. But then what was our sole purpose? Like even in the college you will be given the assignment in this form only. But then you are deviating from the sole purpose of sparse. Our aim was to reduce the memory. Now what you are doing is you are also using the array as well as sparse. Now this is not the purpose of sparse. So I will give user the same concept of inputting the values, but I will not have this array A. As user inputs the value, at that time only I will check whether it is 0 or not, and then accordingly store it. But I don't have matrix A in that case. Getting it? इस तरह से actual काम होना चाहिए. This is what we want to think of. That is job 3. And job 4, this I will call it as read direct. It's not through array. Matrix के through convert नहीं करेंगे. We will be directly reading the sparse. But directly reading the sparse does not mean that you will be forcing the user to input 0, 0, 4 and you to accept it as row number, column number and value. ऐसा भी नहीं करेंगे. Otherwise user will go mad because he will have to calculate every position. User is comfortable in giving the input in this manner only. This is the most comfortable way of giving the input to the matrix, not this. But when you take this input, you will have to directly store it in this form. ये matrix का form कभी आएगा नहीं. But input will look in this manner. When you take the printout, on the printout you will have this from the input side. But internally in the program you will not have any declaration for float A of so many rows and so many columns. That should not be. So that was our job 3. And job 4 is to add to sparse. Just think about it.